Hello and welcome to the 2021 AP Statistics Distributed Best Practices. My name is Bridget Matamoras. I am joined by my associates Darren Clift and Doug Tyson. So we will dive in. And here we go. Doug, you probably know him. He's your bacon lover and an amazing presenter, amazing teacher from Pennsylvania. Where in Pennsylvania, Doug?
I'm from York, Pennsylvania, South Central PA, not to be confused with South Central LA.
And we've got Darren Clift, otherwise known as the Hulk. Darren, where are you coming to us from?
Memphis, Tennessee.
All right. I'm coming to you from Denton, Texas. And here we go. Little disclaimer first, this event's not sponsored by the College Board or the Educational Testing Service. The views, information, or opinions expressed during the Distributed Best Practices 2021 event are solely those of the individuals involved and do not necessarily represent those of the College Board or ETS. Neither the College Board nor ETS is responsible and does not verify for accuracy any of the information during this event. The primary purpose is to educate and inform.
So about distributed best practices, our presentations today are only going to be 5 minutes apiece. You may feel inadequate like each and every one of us does every year. Take the ideas that you like and improve your craft. You don't have to take them all, take one. But if you learn one good thing from tonight and use it to make yourself a better teacher, all the better for you guys and all the better for your students as well. This is one of the AP reading is the best teacher training program you can get as far as an AP stat teacher goes. But the creme de la creme of all of that is our distributed or our best practices, because everybody gets 5 minutes to show their best. You get all kinds of good stuff in a short amount of time frame. So let's go, Bridget.
Okay, so this year's lineup, we have 3 Acorn presenters. The presenters that you're going to see today vary from 2 to 7 years as far as how many years they've been coming to the AP reading. You're going to see activities from units 3, 4, 6, 7, and 9. Instead of just activities, you might see just instructional strategies in general. You can see teacher hacks and so much more than that.
So just a quick word for me. I've done best practices in the past as a presenter, and I'm one of the hosts now. So I can tell you this, if you want me to talk for an hour right now, I'm ready to go. But if you want me to put a good idea into 5 minutes, you got to give me a month to prepare. So please be kind to the presenters. They're trying to boil down a really, really good and complex idea into 5 minutes. That is not an easy task. So the thing that I love about this is what it represents about our community. We share, we give away good ideas, we build on those and make them better, and then we share them back. So in that spirit, when you're watching, just remember, these people are giving you some of their best stuff. Be kind to them.
All right, so a few notes about how this is going to work. If you are watching the video right now, this is being recorded and it's on YouTube. However, you can also access the presentation via Nearpod. What that does for you is it's going to make it easier to navigate through each presentation so that you don't have to go through the video and find the presentation that you want. It's a lot easier to get to the one you're looking for very specifically.
Okay, so here's our first one. It's from John Bennett. We all love John Bennett. John literally brought the house down a couple of years back when he introduced several hundred AP stat teachers to Kahoot for the first time. He's actually been in a skit where he played Jessica Utz as well. John is fantastic. You're in for a treat. John usually is the anchor of this program. He's that great. Real treat to have him first off, and here we go.
Welcome to the Islands, a simulated population for data collection and statistical analysis. The Islands was created by Dr. Michael Bulmer and a group at Queensland University in Australia, and The population actually, it's a virtual population that actually grows and changes over time, allowing students to collect some real data, do longitudinal studies, and run into some of the real world problems that you might run into in collecting data. The link that's here is to the resource site, which has some sample activities and some information on how to use the islands. The sign up link is not currently working, but if you email Dr. Bulmer, he will get you set up, and I'll give you that email at the end of the session. Here's a small map of the islands. You see there's 3 different ones. Each island has a different climate and a slightly different population, so you could do some comparative studies there. But let's get right into the islands. So each island has several cities. Each island has an agricultural field that you can do some research on, and it has some climate data which you can go back and research as well. Those are little squares. A couple of them also have a special building, in particular the visitor center, which gives you updates that they are making to the site as we go, and also a little more information on how to use the islands. Let's get right in. So we're going to go to Vardo, and each city has lots of buildings. Most of them are homes. Each city has also a hall and a school where you can get some information on the islanders. For example, at the hall, you can go to the records and see birth, death, and marriage records. And if you go to the school, you can see the children in that city and what grades they're in to collect data on either elementary or high school students that are of similar ages. Let's go and take a look at a particular islander here, though. I'm going to go down to home number 122, and we see there's 2 people living there. Genevieve Jensen, who's 73 years old, and Axel Upland, who is 72 years old. Now let's talk a minute to talk about time here. Each year on the islands is only 4 weeks long. So it allows you to do nice longitudinal studies that would perhaps fit into a single semester. But it also causes some other issues, which we'll talk about in just a second. So here's Axel. He's 72 years old. Here's his genealogical information and his history, including when he went to school, who he was friends with, what occupations he's had, whether or not he smoked and how much, when he went to university, and also some examples of some medical problems that he's had. You can get Axel to do tests by clicking here, and these are the results of some of the tests that I have run. For example, we found out that Axel was 175 centimeters tall. Notice that they vary a little bit. He grew 1/10 of a centimeter in 3 years. Also his GPA. And here are some of the tests you can run. For example, you could ask him to drink a beer and then try one of these exercises, or perhaps test his coordination. And that allows you to set up small experiments. But of course, before you can run an experiment on someone, you need to get their consent. For example, if I go to Axel's father, who I haven't spoken to before, well, it turns out that Axel's father is not living anymore, but the funny thing is I can still get his consent to perform certain tests on him. And this is one of the things that you have to be careful of. Sometimes the villagers won't give you that consent. Another thing that you might do is you can chat with Axel and have some interaction with him. And one of the time problems is that when you ask Axel to perform a test, it takes him time to do it. So you don't get the results back immediately, and students have to kind of consider that aspect of data collection. So it's got a really full range of things that you have to keep concerned about. And I told you I was going to give you Dr. Bulmer's email address, so there it is. And I hope you can get in and enjoy your time in the islands.
Hi, everybody. Our next presenter is Brianna Kurtz, and I'm going to give you 3 fun facts, 2 of which are true, 1 which is not. and you'll have to talk to Brianna to find out which are true and which one is not. So fact number one, Brianna stood at the Tropic of Capricorn, a famous sign along the Tropic of Capricorn in Namibia. Remember correctly? And second fun fact is that she's been an advisor to 2 different presidents. And third fun fact is that she recently competed in and won a half marathon on inline roller skates, winning her age bracket and also the 70-year-old plus age bracket. Take it away, Brianna.
Hello, AP Statistics readers for Virtual 2021. I'm glad we're getting to have this best practices time, and I am here to share with you today the House of Statistical Horrors, which is a spooky review to save yourselves from the two. My name is Brianna Kurtz, and I did this activity with my AP students at the Crooms Academy of Information Technology, which is a magnet school in Sanford, Florida. And I want to walk you through a review activity and talk about the need for this review. So by the CED pacing guidelines, if you suppose you start school in August and you have a full year course, by Halloween, then you're going to have covered exploring 1 variable data, exploring 2 variable data, collecting data, probability, random variables, and probability distributions, and possibly you could have gotten into sampling distributions by this point. That's a lot of information by Halloween, which means 49 to 77% of the course material by the CED pacing guideline will have been covered by this time. It's a really great time to review with your students. So in order to do this and have some fun for Halloween, I created with my students the House of Statistical Horrors, which gotta love a nice pumpkin about inferring causation from correlation here. So here's the supplies if you do choose to do this activity. You're going to need copies of the student sample responses, which are available from AP Central to remain secure, of course, in your classroom. I used black curtains, Halloween lights, a lot of clipboards, and a good dose of fake blood, as you all will about to see. So here's the prompt that I gave my students. Free response questions are usually not a 4 to 0 as we have seen. Students tend to lose points by, lack of a better word, death by 1,000 paper cuts. So how can we save ourselves from P's and I's? That is what this lesson is all about. So my students will go through a house of statistical horrors where they will experience the missteps of students that scored a 2 on certain FRQs. Then with their partner, they are going to edit that 2 response to save the student and bring them up to a 4. Then they're to write their edited solution and not fall in the traps of others. So this is what it looks like when my students have been going around the room and finding the hidden FRQs of the past and looking for ways that they can help aid the students. And we have a quick video clip here too, so you can hear a little bit of the discussion.
Okay, so they got a 2. Okay, so they got a 2. Or a combination of points is a 2.
So 2.
Okay, so they got a 2. Or a combination of points is a 2.
So 2. There are so many different questions that can be used for this activity. Here's a few examples of past questions that I have used. I've run this activity in my classroom multiple times when I was with the Crooms Academy, and the students did truly enjoy it. If you have any questions about this activity or how to incorporate it in your classroom, please don't hesitate to reach out. I am on the AP Statistics Facebook group page, of course, for the 2021 readers. But additionally, there is my Gmail address and my Twitter handle at Brianna A. Kurtz, in case you want to get any more information. I hope you've enjoyed this time looking at the House of Statistical Horrors and have a fun and hopefully not spooky rest of the reading.
Thanks, Brianna. So up next is Mike Spock. Mike is from Columbus North High School. Mike is going to be an Acorn presenter. He is in his, I believe this is his 4th AP reading. And little known fact, it turns out that Mike actually collects belly button lint to make artwork out of. Hey, Doug. What's up, buddy?
Hold on a second, Darren. That's not Mike.
That's okay. Must be some other different Mike Spock. Okay,
Yeah.
some other Mike Spock. Got it. Wrong. Sorry, wrong. Anyway, take it away, Mike.
Hi, everybody. I'm Mike Spock from Columbus North High School in Columbus, Indiana. I always like to end the year for AP Stats students by going through a presentation of what we had learned, and especially for the seniors, tell them how it's going to apply to them in their future lives. Here we go with the very shortened version of this. The world is a pretty normal place, and while most days will be fairly average, you should expect variability. You may find yourself in a position where it is simpler to treat groups of people based on their averages. This could happen in your jobs. But you will remember to expect and value variability and treat people as individuals, not just data points. Sometimes the world is going to seem skewed to you, but typically it's just your perspective and which direction you're looking. Everyone has a different view of what's normal. One thing that I have learned through life is that there is a very strong positive relationship between the effort you put into something and the reward you get out of it. Always remember to hypothesize and test your hypotheses. Experiment often. Little experiments happen in life. Become aware of your biases. We want a diversity of opinions. We are all biased, each and every one of us, and a biased decision will always be wrong. We talked about independence in this class. But are events independent? I love this quote from Martin Luther King. In a real sense, all life is interrelated. The agony of the poor impoverishes the rich. The betterment of the poor enriches the rich. We are inevitably our brother's keeper because we are our brother's brother. Whatever affects one directly affects all indirectly. You'll find games you want to play. You'll find risks that you should take, whether you're going into business or in the medical field. You'll find some games you shouldn't play, and you'll be able to analyze that. You in life will face some decisions you don't want to make, where all of the things you're choosing from seem like bad things. I wish this didn't happen to you, but it will. It happens to all of us at some point. It may have already happened to you. You'll have some big wins and you'll make some big mistakes. It's normal for that to happen. Sometimes in life, you have to look at the possibilities, not the probabilities. Sometimes it's the hope or the opportunity that's the important thing to look at. This is very true. If there's one thing you took from this class, you've learned about p-values, and in your future studies and jobs, it's very likely that you're going to come across p-values again. And you know what to do. If the p-value is low, you'll know there's something significant there. You understand what they mean. You understand what the data is telling you, that the results are unlikely to be explained just by random chance. You'll have to make decisions that you're only 95% confident about. This is something I feel very strongly about. Get involved, try new things. On average, new things are positive. Work hard. Little improvements do add up. Be a part of changing the world. So let's have a whole bunch of people join our world right here. Each of these is a little stick person. I'm not even sure what we're measuring here. We've got an average of 295, and one person decides they want to change the world. They want to improve the world, and they go and they make a little improvement. And we don't really notice this improvement. Have they changed the world? Yes, of course they have. Okay, but we don't notice these small improvements. We need a lot of small improvements to be able to recognize what's going on here. But maybe a group starts making improvements. There we see a small change to the average. Really can't see the world changing yet, but small improvements are building up. But in today's world, maybe this idea starts to become popular on the internet. More people are joining in. We get a greater rate of people making this small improvement. We start to notice it. We start to get, look, new world records out here. We're thrilled that this is happening. We've still got people over here. What are we going to do? Are we going to help them out right here? We're still making these small individual improvements. Maybe we need to help each other out. Maybe it really goes viral right here and lots of people join in on this. And so now we're seeing change happening at a rapid rate. And, you know, we've still got a fairly normal distribution going on right here. We keep breaking records. We've still got people over here. The variability within the world is increasing on this. We've got noise. We've got activity. This is beautiful, this happening. All of these small changes changing the world. You can be a part of this, even with small changes, whatever they may be, whether it's your idea or you find somebody else's good idea. Get involved, make those small changes, change and improve the world. So remember, with great power, all the extraordinary things that you have going for you comes great responsibility. Remember to be excellent to each other out there. And as we've learned in stats class, the key to success in anything you do is communication.
Thanks, Mike. I appreciate that. And up next, we've got Thomas Rothery. Looking forward to Thomas Rothery. Thomas is actually in one of my reading rooms this year. Let's see. What do we know about Thomas? Let's see. I think he did the welcome video. Yeah, he did the welcome video. And I think it's his kid who is Luke Wilcox's father. Not for sure about that one. Anyway, take it away, Thomas.
Hi, my name is Tom Rothery. The title of my presentation is Testing Inferential Slopes to Verify the Beauty of the Golden Ratio. All right, purpose of this activity. This involves Unit 9, Inference of Quantitative Data with relation to slopes. In my opinion, this unit needs a little love, okay? It comes at an exhausting time of the year. At the end of the year, students are tired, teachers are tired, and for the most part, most of the practice I see involving the sections involves population slopes equal to 0. And so I wanted to create something a little bit different for my students to work on. All right, so what is my population slope going to be? It's going to be the golden ratio. Okay, we're going to test whether this is true mathematical beauty, since we often represent it through our artwork or architecture or the Trillion Man, where each segmented area is drawn anatomically in a way that supports the golden ratio. And this is supposed to represent the perfectly drawn human being. Okay. However, when I do such activities in my class where I have students measure anatomical parts, I find that them, including myself, sometimes don't get values that are close to this ratio. Okay, 1.618, our approximation for a gold ratio. Okay, and maybe we're just not good with our measurements. Maybe we are just not mathematically attractive. Maybe this is outdated. Who knows? Okay, so let's test this and see whether this may be valid or not. Okay, so I take these measuring tapes and I tape them on my walls in my classroom horizontally and vertically all over the room and have students stand up next to them and create measurements. Some will use their app on their phone. This actually works very good as well. Okay, we do this in centimeters and we do some noted anatomical lengths. Okay, we'll do hand length versus palm length, put them in a table that students have on a given worksheet, create an ordered pair. Eventually, I'm going to put these in L1 and L2 in my TI emulator on my computer for everybody to see, okay? And then move on to our next pair, okay? We're going to do head length versus top of the eyes to the chin, okay? Create some measurements from each, all right? Create an ordered pair. That will go in actually my next row for my L1 and L2 in my emulator, okay? Do one for Hulk's math, belly button length to the floor, and then belly button to the kneecap, okay? Create some ordered pairs, put those in L1 and L2. Arm, okay, which means shoulder to fingertips versus elbow to fingertips. Create some measurements for each. We'll eventually store those in our graphing calculators for L1 and L2. And then finally, entire length, okay, the height versus belly button to the floor. Assume Wookiees have a belly button. Create some measurements in centimeters, okay, ordered pairs. Eventually, every student will create 5 pairs of measurements to make coordinates, okay? And they'll get a table that looks kind of like this. They'll make a graph of their points, okay? Here I counted by 20s. On their graph, they'll probably count by 10s, and it's only because I have people as short as Simone Biles, professional athlete, versus Wookiees and superheroes that are between 7 and 8 feet tall. Okay, when my students put their data into my emulator, they got something that looked like this. Okay, I asked them on their worksheet to help describe estimates for alpha, beta, and sigma, and most of it they could do on that simple command, the linreg a plus bx command. Okay, further, if they create an L3 column, okay, of course, and do residuals there, they can make that calculation for an estimate for sigma with that S, okay? They can draw the line in, and then further, we will describe these 3 things in detail on the board with a good discussion to make sure that students understand the differences between each of those. Okay, they're there on that PowerPoint if you want to pause it at that time. Okay, now we do the true test. Okay, students don't know what they're actually finding. Okay, they were not aware of this target of the golden ratio. And for example, I took my period 5. I put their class photo, okay, in terms of my attendance on the board for everybody to see, and I told them, you are my most attractive class, okay? You are mathematically beautiful, you are Hollywood attractive, and I chose to use you as my sample of all beautiful people to test whether we believe this ratio to be true, okay? And so there's the question at hand. There is the null and alternative hypothesis, okay, where the golden ratio is listed in the null and alternative is not equal to, and we describe it to the right. Okay, we do the conditions. We already found that it was linear, okay? We do a test for independence. The nice thing is that you've already got values for residuals in L3, and that helps us do graphs for these in our calculator pretty easy. I often use this one to help represent ideas for normality. Some people ask, is that an outlier? And it happens to be. Sometimes we don't get perfect data, but we will look at it and make some discussion about it.
Hey, it's not fair when you do it yourself, Thomas.
And it happens to be. Sometimes we don't get perfect data, but we will look at it and make some discussion about it. Okay, and then looking at whether our residuals, left to right, are equally spaced from the beginning to the end in terms of its height. Okay, are they random? No, they are not random. It is 5th hour. But we discussed what would it mean to be truly random, and again, we had to do things this way because that's the only data I could collect information from. We eventually used our formula to find a test statistic, okay? And you'll find that in most cases, and I did this with 4 different hours, okay, your sample slope will be close to the normal, the golden ratio as it was for me, okay? But we do this all out pretty much by hand until we can do a TCDF. Remember that when we get a proportion, we have to double it because our alternative is a not equal to, it's two-tailed, and we get a conclusion, okay? Some follow-ups is that I do have a table that's provided. All your calculations that you found in this exercise can go in that table. You can work backwards, and then an exercise with residuals, okay, where you do common residuals and add them up to see if you're anywhere close to 0, and then doing them with absolute values, and which one may be more appropriate, okay? You can create words for students who are close to the golden ratio versus not, and there may be someone who is not close, and it's sometimes fun to recognize that depending on your class, okay? There's all the information that you need. If you have any questions, feel free to contact me. Have a great day.
Thanks, Thomas. That was actually pretty cool, and I got to tell you that I actually love me some Vitruvian Hulk right there. That's pretty awesome. Yeah.
Thanks, Darren. All right, next up we have Greg Fisher from Winston-Salem Forsyth County School Career Center in North Carolina. And Greg was an ACORN last year, so he doesn't know what the in-person reading is like. Poor guy. But we will educate him soon. Here we go, Greg.
For some review activities that I've used in stats, but I've also used in Algebra 1, but they can also be adapted for other subjects such as English and social studies. The first one is called Slapjack. Basically, as a teacher, I put a board of about 25 answers on a table for each group to use. So if members are competing against other members in their group, usually I give the winners a small prize. And basically, I'm going to ask a question, and they want to be the first person to slap the answer. If they're the first person, they get 2 points. If they are the second through remaining people to touch the correct answer, they get a point. If they touch the wrong one, they get -1 point. I usually show the slide. just to show them how to do it, but let me just do a demonstration with you. So I've placed this board for the students to see. I am now going to give a problem such as when I interview people at the YMCA and I ask the first 30 people, how much do they exercise? What am I doing? So it is a convenient sampling. So the yellow touches it, and right behind the yellow, the white hand touches it, and then the bumblebee touches the wrong answer. So what's going to happen is the yellow hand is going to get 2 points, the white hand is going to get 1 point, and the bumblebee is going to get -1 point. The reason why I've put different letters here is so that it's very easy for me as a teacher to say, okay, the answer was T, convenient sample. Makes it very easy. So again, these are the scores. So I'll do another example. This time I give a problem. It can be either done by the PowerPoint or orally, where the correct answer is match pairs design. And so this time, the white hand touches match pairs design, the yellow touches block design, and the bumblebee doesn't touch anything. So the match pair is going to get 2 points because she was the first person to touch the correct answer. The yellow hand is going to get -1, and the bumblebee is going to get 0 because the bumblebee didn't touch anything. I also use this when we get to the end of stats and we're talking about the different inference tests that students can use or different procedures. And I usually put all 14 procedures down and let the students try to be the first person to touch the correct procedure. Usually I have them read something and then be the first person to touch. The next game is Bluff. It's where you have half the class compete against the other half of the class. You're going to simply ask Team A a question. Students will stand up if they know the answer. I, as a teacher, will choose one student. If they get it right, then Team A gets as many points as the people standing. So it's called Bluff simply because people can stand up when they don't know the answer, aka bluffing. I do not randomly choose students simply because I try to choose students of similar caliber. So if I choose the very smart person from Team A, then I will choose the very smart person from Team B, etc. All right, so I begin with a very simple question. I start with Team A, and I give them time, and I say, what is the answer to number 10 from the worksheet from last night? So 3 people stand up, and so I now choose student number 13. Student 13 gives me the correct answer. The correct answer was 2, by the way, in case you were wondering. And so now what's going to happen is skewed left is going to get 3 points, and then they now sit down. And so now I ask Team B a question. And this time it is problem number 12 from this worksheet. 5 students stand up. I think that student 23 is very similar caliber to student number 13, so I choose student number 23. He gives the correct answer. So skewed right now has 5 points, okay? And so play continues. Let me do an example when somebody gets it wrong. So now I ask another question. Skewed left has 4 people standing. I randomly choose a student. And student number 9 and student number 9 is wrong. So they have 4 people standing. So skewed right can steal it for half the points, so they can get 2 points. So I just ask somebody, does anybody know the answer? Student number 17 raises her hand, and she gives me the correct answer to the original problem. So they're going to get 2 points. If I find that the problem is going to take a fair amount of time, what I will do is I will say, okay, Team A, you work on this problem. Team B, you work on this problem. And then what will happen is the students who are stronger students, they will not only do the problem for their team, but they will also do the problem for the other team during the allotted wait time. It's a very good.
Going too long, making me mad.
Good game, very easy to implement anytime you're reviewing. Last one is simply around the hall. Basically, I usually put about 10 problems around the hall where the top represents an answer, the bottom represents a problem, and then I just put letters here just to help me as a teacher keep track of what the students are doing. And so the students in groups of 2 and 3, they just start at a problem. So let's just say I start right now, or these 2 students start at this problem. they do the problem and they say, okay, they're looking for the word ball. So they go around the room, they look for the sheet of paper that has the word ball. And so then they will walk around the room to the sheet of paper that has this. So on their paper, they're going to write down the letter T, and then they're going to now solve this problem. What president number is President Obama? They recognize that he was the 44th president. Then they will walk to this sheet. They will then do this problem here. They'll come up with the answer, and then they'll go to the letter B. And so this is just very simple on how to do 3 problems. Typically, I do 10 problems. This is a very quick something that I did when it came to Z-scores, and I've put it in the handouts for you. And I just put these around my room or out in the hall. I like to include letters, and I don't have them spell out a word. I have them spell out a phrase that I know, and that's it. Let me know if you have any questions.
All right, next we have Stephen Blinder from Frontier Regional School in South Deerfield, Massachusetts. Steve is an Acorn presenter, so we hope that he decides to present even more after this year. Take it away, Steve.
Hi, I'm Steve. Welcome to Best Practices 2021. I'd like to talk to you about my ideas for a final research project. I have students design, implement, analyze, and present an experiment based on a research question. They begin in January, and their presentations are after the AP exam, typically right before their final exam. I make this project 50% of their 4th quarter grade. And some of the comments I've heard from teachers in the past are, I don't have time, I only get 1 week of review before the exam, etc. And so what I've done in the past is I get them, whether they work by themselves or with a partner, come up with 3 proposals sometime in January. By February, I've helped them choose a proposal. And by March, they've made a plan on how to conduct it. And by the end of March, they will have conducted a dummy trial to work out kinks in their process. And by April, they are conducting real trials and collecting real data. So what makes this project unique is I'm sure many of you do a similar kind of project. Well, I'm going to save that for the end and first talk about some different projects that my students have done in the past. Some are simple, a taste test. Can they tell the difference between expensive water versus tap water? And a true experiment here was do cell phone conversations affect a driver's reaction time? We certainly couldn't have students driving around town with a cell phone. They brought students into the media center instead. And the treatment was, while students were playing this computer game, they had some students talking on their cell phones and others not, and then they analyzed the time it took to complete the game. Some other projects that students have done in the past for me. One student got 24 seedlings and then studied which of 3 treatments, water, sugar water, or Miracle Grow, help the plants grow the best. One pair of students studied mice, and for this project they had to go right to the principal and explain how they were going to treat the mice during the experiment, how they would return the mice to the pet store afterwards. They got approval, and so what they did with the mice is that they had a maze with cheese at the end, and they played music for some mice and no music for others, and they tried to study if the music would help the mice complete the maze faster. My students have done stealth experiments before where the subjects go in a room and complete a quiz. They actually end up throwing the quiz out. They've told the subjects they can get 1 piece of candy, and the actual treatment here is whether the subjects take 1 piece or take more than 1. The treatment being is the researcher facing the subject or facing the door to see whether the subjects follow directions or not. Bounty versus store brand paper towels, which hold more water. And so what's the real question of interest here? Well, that leads to the benefits of doing a project like this. question of interest. Doesn't really matter which one holds more water, although that was part of the experiment. With the real question of interest in that one was, is it worthwhile to spend money on a name brand if the store brand performs just as well? So clarifying that question of interest is a skill they can take with them to any course that they take. They will see certainly the applicability of much of what they've learned throughout the year and learn how to present. No student should go on to higher ed without having done a serious presentation before. And it keeps them busy to the final whistle, which I think we can all appreciate. So what makes this different and from other projects? And to me, it is all in who is invited to the final presentation. I invite administrators. These people, principals, superintendents, they deal with students with issues. They deal certainly with parents with issues and budgets. And they come to this presentation, and for an hour and a half, they can forget it all. And they can see what the students can do. And it's a real, they look forward to this every year. It's an excellent opportunity to
going a little long here, buddy. Let's get it going, okay?
impress your bosses. And then the absolute best part of who you invite is I get a list of who signed up for the course for the next year. And I invite next year's students. They will get a sense of the course, as many are not sure what it's all about. And they'll get a glimpse into the rigor that's involved in this course. Some may not take the course seriously when they first sign up for it. And they get a sense of just how serious a course that it is. And another side benefit to inviting them is that they will frequently already start thinking about what they want to do for their final project. So I thank you for your time and have an excellent evening.
Thanks, Steve. Hey, the next presenter is one of our regular contributors. Hao Nguyen Vu is out there in sunny California. And while you might think he'd be tempted to just take it easy and be laid back because, you know, it's California, he is always looking for new ideas. If you don't think you can keep up with today's tech, he's here to tell you you're wrong. Take it away.
Hi, I'm Hao Nguyen Vu at Coastline College in California. This video has been shot entirely on TikTok. Reasons you should use TikTok to teach. 1. Our students are on it. 2. C1. That's it. Bye.
Just kidding. Well, half kidding. That is a big part of the reason, but there are other reasons as well, so let's keep going.
3. It forces us to focus on the most important point. TikTok is 15 seconds, or up to 1 minute. We must fit everything in. No extra blah blah. Here's 1 minute.
Let's talk about the difference between random selection and random assignment. Random selection is about selecting your sample. So you have a population, and if you randomly pick out your sample, for example, by blindly pulling names from a hat or having a computer randomly generate a list, that's random selection. Now, random assignment only applies to controlled experiments where some people go into a control group where they're getting the placebo and other people go into the experimental group where they're getting the treatment. In that case, you already have your sample, and then you assign some people to the control group and you assign some people to the experimental group. That's random assignment, right? In summary, from population to sample, random selection. From sample to either control or experimental group, random assignment.
4. TikTok has easy-to-use editing tools. Sounds include preloaded music. Effects include image and video insets. Text adds text in video. Within text, duration sets beginning and ending time. Text-to-speech is what you're hearing now. You can interact with other videos. You can stitch your video to another clip.
Because first of all, you had it backward, and second of all, it doesn't always work. Type 1 error is when you incorrectly reject the null hypothesis H0 and incorrectly accept the alternative hypothesis H1 or HA. The vast majority of the time, the research question or research hypothesis is the same as the alternative hypothesis H1, so you falsely accept it, and that makes it a false positive. But even that doesn't work all the time because sometimes the research hypothesis is the null hypothesis. So type 1 error in that case is a false negative. So you can use false positive and false negative in specific cases, but in general, you have to identify the errors as type 1 or type 2.
You can do it side by side with another clip.
You should have done the regular assignments instead of now asking for extra credit. What is in the syllabus?
Now for some downsides. 5. App is only on phone. 6. Vertical video is not good for classroom projector.
That's it. Thanks for watching. And since my 5 minutes are not up yet, let me show you another feature of TikTok, and that is you can use the sound from a different video and lip sync to it.
What is this job? And they say, okay, here's what we need you to do. We need you to make children know math. Wow. Do they want to know math? No, they don't want to know it. You need to make them know it against their will. Who are these children? Just whatever kids live near the building. How much do I get paid? About $10 every 4 years. What if I get really good at it? What happens? Nothing. Nothing happens.
Dang! 4 minutes and 59 seconds. I was just about to go all Professor Hulk on you. I actually got the nerdy Professor Hulk shirt on, by the way. It's actually a gamma function. Cool. Cool. Hey, Doug, we got one more.
Hey, Darren, speaking of nerds, we are full of nerds at the stats reading, and one of the biggest nerds is up next, Bridget Matamoros.
And Bridget, this is all Bridget. This is all Bridget today.
Yeah, Bridget's here as a presenter, but what you all need to know is that Bridget really did almost all this work, and so when you see this and get great ideas for your classroom, you need to thank her for putting the efforts in, as well as all the presenters for the great ideas.
Absolutely.
You guys are too nice. Howdy, wonderful AP Stats teachers. It is a pleasure to bring to you one of my favorite activities that I wrote alongside my teacher BFF, Catherine Jingo, AP Government Teacher Extraordinaire. Okay, so the learning targets that go along with this, we use random sampling methods to estimate a population parameter. We compare different sampling methods, and then we get to explain what's meant by sampling variability and how it can be reduced. So first of all, a disclaimer. I mean no disrespect at all to jelly blubbers or random M&Ms. I know many teachers who use them. I did myself, but I realized I wanted to include some more relevance to the idea of sampling methods and polling. So here we go. First thing is we got to make it relevant. Students need to learn to pay attention to current events. Most don't. Lord knows I didn't care when I was their age, but looking back, I wish I had learned to pay attention. So modeling this behavior of staying abreast of the political activity of our country is crucial if we want educated citizens who will take their right to vote seriously. So that's the end of my soapbox. So after doing this for a few years now, Kate and I have settled on dividing the work so that she's in charge of finding recent and relevant poll results from a reliable source and breaking down the methodology. And then I'm in charge of preparing the fictional population for sampling and gathering the materials. We both contribute to the final PowerPoint presentation. So here are some examples of previous poll questions we've used. So this was a poll by Monmouth University back in 2017 when tensions had escalated between the US and North Korea. So at the time, this was big news. Sure, there weren't many students who paid attention, but some did. So this became a teaching moment on current events, and Kate was able to lead a quick discussion about international relations. So we also discussed the purpose of the follow-up question there and about how people are not sure, and we want to ask them that follow-up question in order to attempt to get a better estimate of the population parameter. And yes, using the correct vocabulary, statistic, and parameter, it's critical early on. So these poll questions can quickly become outdated if you notice. So here's the one we used this past year. So this is not political, this is simply when did you decide who to vote for? Not who, just when did you decide? So our administration didn't have any problem with us using this question. So before we dive in, we take the time to break down the polling methodology so that students can learn to identify when a poll is reliable. We talk about things to look for, such as who was asked and how many people were polled, as well as how they were contacted. So by this time, we've already covered types of bias. So I ask students to name and describe certain biases that would pop up from these methods and if there's a way to reduce them. So for example, the Quinnipiac poll called people on landlines, and kids chuckle when they hear landline because no one has those anymore. So that would lead to undercoverage because not everyone has a landline or a cell phone, though that might be a smaller proportion of the population. A much more prominent problem, though, would be non-response bias because not everyone's going to answer the phone, especially when they don't recognize the number. So we discuss how it's impossible to completely eliminate these biases, but they could at least reduce non-response bias by calling people multiple times, which was exactly what they did. So most poll questions have multiple possible responses, but I need them to be binary. So I had to rephrase the question to have just a singular cutoff date for when they had decided who to vote for. So this made it a yes or no question. And so then the part that takes the most work is creating the fictional population to sample from. So based on the information given by Quinnipiac, I took the proportions of each political affiliation and I divided them into subgroups. But this is not as interesting as having some additional groups. So I fictitiously took the Democrats and Republicans and I separated a portion of them into extreme left and right groups. So this makes it a little more interesting. And now we're ready to start sampling. Well, almost. So just like jelly blubbers and random M&Ms, I need handouts that have the fictional population to sample from. So we use this side for most of the sampling methods, and then this is stratified and cluster. So I print these on cardstock, double-sided, and I use the pocket sheet protectors so that students can draw directly on them with a dry erase marker. So let me zoom in so you can see the detail on the first row. So you'll notice that's a lot of work to create. Luckily, I do have a particular former student who is coding a web page that will allow you to input the details for a fictional population, and it will produce a printable PDF of both pages for you to use. So I'll be posting that link along with the activity materials as soon as it's ready, hopefully no later than mid-August.
Hulk! Smash!
So now we dive in. We do the self-selected sample first. Students pick any 20 people on the jumbled side. They calculate the percent of yeses, and then I have them plot their results on a class dot plot with those big adhesive chart paper pads that have graph paper that would look something like this. Next, we'll do the simple random sample. You cannot forget to have students seed their calculators or you'll have tons of responses that are exactly the same. So a simple random sample might look like this. Altogether, their results are going to have hopefully less variability than the self-selected sample. For the systematic random sample, I have them pick a random starting point using the calculator. And then for a little bit more variability, I have them use the calculator to get an ordinal number from 1 to 5. We do talk about and emphasize the fact that a systematic random sample is only random if it has a random starting point. That's occurred on the AP exam before, so that's critical. So they use their ordinal number to count to get the people in their sample. and then their results might look like this. And then we do the weighted stratified sample, and so we'll use the opposite side of the handout. They'll pick the same proportion of the sample that is corresponding to the proportion of the population for those different groups. This one needs the most vertical space because it's going to have the least amount of variation. We only talk about an unweighted stratified sample and how it might compare to a weighted stratified sample, but we don't actually do this one. Last, we'll do a cluster sample. I have them use the calculator to randomly select one person. They'll build their cluster out from that central point. So if it's in the middle of the page here, they might go out this direction just until they get 20. Cluster typically tends to have the most variability. And the reason why I have them use that organized side is because if we think about cluster samples being geographical, people might live in an area where people around them have similar opinions. But we do talk about how the results might be different if we had used the other side. All right, so to sum things up, we discussed their overall experience with the easiest and hardest sampling methods. Kate will talk about what that means in terms of cost from a political perspective. We discussed the accuracy of the results from our sampling distributions. Kate will talk about how if a politician wants a better estimate, they'll spend the extra time and money to have a good poll done, but if that's not their concern, they might go fast and cheap. Sampling variability is easy for them to identify as a good way to gauge accuracy. Lastly, we'll briefly talk about margin of error. It's not a long discussion, just so they understand what it means if they see it reported on TV. That also means that when we get to confidence intervals in the spring, it's not the first time they've heard it. I give them the actual results at the very end, and we build a very informal interpretation of that interval. And that's it. Thanks for watching. Feel free to contact me with any questions. Okay, so where can you go to access all of these amazing best practices? So Bob Lachelle's website, he hosts all of the videos. He will have the Nearpod presentation posted, the YouTube video presentation posted, as well as a link to a Dropbox folder where you can find all the handouts and the presentations that the presenters submitted. So this is Bob's website. Obviously, it doesn't have this year's information yet, but it will be there. Just give him a little bit of time. Thanks for tuning in and watching these 2021 AP Stats Best Practices. We will see you next year in the beautiful, but hopefully not so scorchingly hot Kansas City.